Okay, Year 12, conservation of momentum. This is the example from our last little demonstration which I gave you, which was about the train. So we had train, and there was a spring between them, pulled them apart, and they ran into each other. So this is the maths of it, if you like, and this is it drawn out. So I'm going to do this as a worked example, so you can get an idea. I'm then going to do another one on a sort of slightly different idea of how these collisions work and how the closed system works. So what I've got here is, remember this was a model, so I can now put some real numbers in. That's a 1,000 kilogram train, that's a 1,000 kilogram train, that's a 1,000 kilogram train, and that's a 1,000 kilogram train. This here is the spring in between it. Pulled it apart, let go, and we watched what happened. That was in the last video. Question: the spring exerts a force of 20,000 newtons on the left train for 2 seconds. Calculate the final velocity of the right train and explain the physics principles. Okay, now, first job would be to draw a force on, so you understand what on earth is going on. So the spring exerts a force on the left train. That will be that way, because remember we pulled it apart, so the spring is going to exert a force on the left train that way. 20,000 newtons. This one here will have the same. Why? Newton's third law said for every action force, which you could consider this to be, there is an equal and opposite reaction force. Forces are always in pairs. Sometimes it's difficult to work out how the pair works, but they are always in pairs. Calculate the final velocity of the right-hand train. So we are given, it is 2 seconds that this force is applied for. There is a formula that says change of momentum equals force times time, which we talked about in the previous video. So, change of momentum equals F, which is 20,000, times 2. So, the momentum equals 40,000 units, kilogram, meters per second. That means that both of those trains are going to get that momentum. Because this is the first example, I've made it really easy. I've given them the same mass, so it means they are actually going the same velocity. This one here is going to go that way. The question has asked you for the right train. So it means when we get to our final answer, we need to say it is going leftwards. Okay, so there's your change of momentum, 40,000. The formula for momentum equals mv. Now again, pretty sure we talked about that in a previous video. So 40,000 equals the mass times velocity. 40,000 equals the mass, which is, no, not 1,000, it's 2,000 times v. 40,000 divided by 2,000 equals v. 40 divided by 2 is 40 divided by 2. Anybody? Is it 20? So v equals 20 ms minus 1. Which way? So this train here is going that way, left. If you remember, it is a vector quantity, which means it needs a direction. Explain the physics principles. Physics principles need to say things like, it's a closed system. That means all the forces are contained within the system. This is considered to be a frictionless track, so I'm ignoring friction, which means that during the collision, all the forces from the spring act towards accelerating the trains. So there is no loss of the force to somewhere else. There is nothing going on with the track. So my assumption, my physics principle, is that this is a closed system. That means that whatever force this spring gives to this train here will be the same as what's given to that train there, and the forces are contained within the system. So forces are contained within the system. And we can say that, we should also say that friction is considered negligible. Anyway, the video is getting too long now, so we're going to stop there and look forward to the next video, which will be on this similar theme. Thanks.